Okay, I'd like to introduce Ginger Butcher. She's the NASA Aura Missions Education and Public Outreach Coordinator. She's going to tell you about our activities.
Good morning. I'm essentially still doing education and public outreach for as long as they're supporting that at NASA. Done a lot of great stuff in support of air quality, particularly since it's one of the three main goals of the Aura mission. And let's see. So my job essentially is to communicate to the public what we're doing, what the satellite data that we're getting from Aura is doing to help us better understand the chemistry of our atmosphere and particularly what's going on in the troposphere for air quality. This includes general media, trying to work with some of our folks at the Office of Communications and through NASA, but also engaging the general public and kids. And how do we sense gases in the atmosphere and how do our instruments work? What kind of data do we get, and what can we do with it? So the EO's office, Earth Observation Systems, were one of the three big satellites, Terra, Aqua, and Aura, and their program office puts together a lot of really nice materials, including posters, and you may have seen the lenticulars, and the Earth at Night puzzles that are out on the table. Those were all produced by their office. So this is one of the things that they're working on right when I started working with the Aura mission in 2011. The lenticular was really popular, so we went ahead and did a global version and a Europe version. And this one actually has one more panel. There's sort of four on the Europe one that has population density, which I think is kind of interesting. And then this one, if it works, it'll show you kind of the animation of our lenticular that you can see out on the table. These have been very popular in a lot of the large conferences that NASA supports. They go to AGU, AMS, a variety of conferences across the globe. So we also produced a video for mostly for education, for use in the classroom. It's also really good for the general public. This one kind of focuses on the LA story and Hoppenschmidt and how he pretty much figured out that whole ozone, how ozone was created. And I love this picture with the Boy Scout drawing little tears from the burning of the Los Angeles air. What we also did is work with the American Chemical Society, and they have a publication called Chem Matters. It goes out to 10,000 chemistry teachers, classrooms across the country. Also have copies of that out front. We did two articles. One was on the stratospheric ozone, and one was on air quality. Again, a little bit of focus on how we solved that problem. I think it's just really fascinating how they came up with how ozone is not coming out of the tailpipes or the smokestacks, but it's actually happening in the atmosphere. And it's a great, great chemistry example, particularly in high school. Following that up, Brian and I actually worked with National Science Teachers Association, and we did a webinar as part of this project. We talked both about the air quality and the stratospheric ozone. The webinar is now archived, and any of the NSTA people can get on and watch it. It's a good experience. This is another interesting thing. So if we wanted to expand our reach, how do we get out to the general public beyond the few little conferences and outreach activities that we do as NASA support? So I kind of found this company, and we put in an IRAD, an internal research and development grant at Goddard, and got some funding to develop activities to work with these small electronic components. The company we worked with developed some of the components that were needed for us to do the experiments, and essentially they're electronic circuits that snap together with magnets. They're really easy to use, and some of the electromagnetic spectrum outreach activities I was doing were very complicated to put together, the alligator clips and the resistors and everything. So this made it really easy. And so what we did is a whole booklet that went with this that focused on energy, electromagnetic energy. How does NASA use it? How do instruments use it? So one example, my favorite one, is the measuring the atmosphere. We like it too. So These are some pieces of pages from the booklet that come with the kit. And this was measured in the atmosphere. We did this at Earth Day and the USA Science and Engineering Festival, which, by the way, there was over 300,000 people attended that event in Washington over 3 days. And we had a exhibit at the NASA booth, and it's the measuring our atmosphere. There's 3 bottles, and the water in the bottles represent the atmosphere. If you've done the Why is the Sky Blue, the light scattering activity, it's similar to that. And essentially, they use the circuits to make an energy meter. And they measure how much light's reaching the bottom, or the surface of the Earth, and then they measure how much light is being scattered, and they realize that more light scattered, there's more stuff in the atmosphere. And that stuff that we're looking at is what we're trying to measure, and that's what tells us about the health of the ozone layer, where pollution is, how's it doing. And the final part is I show the 2005 and 2010 images of NO2, and it's always the question, this is what it looks like in 2005, what do you think it's like in 2010, is it better, or is it worse? Everybody says it's worse. 1 in 100 might say it's amazing, and then you show that, and they're just, wow, I mean, parents and kids, everybody. You recognize this fellow? This is a Beautiful Earth event. It's one of the NASA, it's a NHOS, or one of the Rose's proposals for education, Beautiful Earth. They basically combine music from Kanji Williams on the violin. In this case, we had a singer with these amazing NASA visualizations. They did this program for kids. This one we did at the beginning of June. There were 140 kids, and combined this presentation on science on the sphere. And if anyone's seen it, they're in about 110 museums and science centers around the globe. It's a 6-foot sphere that they project 360, and you can show all kinds of earth science data, particularly. They also have planetary data. So we put together an air quality show, and these images over here are also projected on the sphere, but they're actually interactive. There's an iPad app that you can actually pull up data, and we've gotten the NO2 data into this NEO program, and you can actually load up and look at time series and do investigations right on the sphere from the iPad. And so here we're looking at change over time of NO2 in the region around LA and the region around Beijing. This is also available on the web. It's NEO, NASA Earth Observations, and you can look at the NO2 data as well. And it's not quite the color scale that you're used to, but it's really good with working with people and in the public. We also resurrected the ozone garden. Jeannie Allen, who worked with our mission years ago, had put together the ozone garden. She worked with Margaret Pippin and Jack Fishman, who are out at Langley. This time we were able to fund it so that we could actually put the ozone monitor out in the garden. This is one of the Go3 projects. This is the inside. We put up an ozone exhibit on the inside, and here's our Go3 ozone monitor, and it's going to start uploading as soon as I can get the security regulations for putting a laptop on the NASA network, but it will be uploading hopefully in the next couple of weeks to the internet, and so you'll be able to see real-time ozone measurements from NASA Space Flight Center. We're also working with the media, but we have a really great website called the Earth Observatory. They put out articles every day, particularly Image of the Day. Probably many of you have seen them. They also do features. So they've done a number of Image of the Day with our data, and particularly showing air quality. And next week, actually on Tuesday, they're going to launch a new feature about air quality. Kind of combines a lot of the stuff that ours has been doing over the past 10 years, and also additional missions that NASA is involved in. And next week, we're also doing a live media event. We're going to do what's called live shots. They're going to have 4 scientists at Goddard who are going to be available to local media centers around the country. and they can get like a 90-second spot to ask the scientist a question. So this is the release that's going to go out next week. And we're looking for, basically, we're starting to compile these messages now, and if you have specific messages, like the one about the air quality getting better, that's kind of the key one that we're trying to show, but then there's also still need for improvement. We'd like to hear from you, and if anybody knows, maybe they've had media training, or they know somebody or a colleague who's had a media training and works well with camera, would be interested in participating, we'd like to get you in touch with your local news source that might be picking up the story. So I'm working with Tracy, so you guys know her, her email address is there. She'll get you in contact with our counterparts at NASA and try to get you guys involved, because I think it's very important that we're getting a local story out. What they did is they compiled, NASA compiled several major metropolitan cities, change over time for NO2. Here's one just for the kind of the New York, New Jersey, East Coast area. They're putting together for, I think there's Chicago and Houston and LA and so forth. So we're trying to put these local images out there so that hopefully the local news will pick it up. So that'll happen next Friday morning. So you have a week, so contact Tracy or myself and we can get you in contact. And that's what I have, I believe. So any questions? I have a question.
Yeah.
All right. Is there an interest in focusing on wildfires as you move through space? Actually, for this media event, yeah, actually one of the scientists that's going to be on the live shot list is Doug Morton, and he works with a lot of wildfires and works with Landsat data that analyze that. I haven't done a whole lot because that's not been a lot of the stuff from the right.
So, I was just going to make one comment. I think it's very good to hear that you're, promoting this. What does the data actually say? It's unfortunately something that the message gets very lost in our society. Spent 2 weeks hearing about how air quality is bad, and so actually getting the facts out is very, very.
Yeah, and that's what's great about the NASA imagery is you can show this large area, global, but so large area, not the individual ground-based sensors. So you can kind of get that nice big snapshot right there.
Yeah, following up on Howard's people actually relate to NASA and NO2. You tell them something that's defined, if we get translated into some kind of public health, which could, right?
I just did this activity where there's like 300 students that came by and I'm showing the NO2. All I have to say is that it's a pollutant and where it's coming from, pipe and smoke stacks and so forth, and say that the red is where there's more and then they kind of equate. You don't have to say, well, it's part of the form reaction. Oh no. You don't have to really go and help. You just say it's a pollutant together. And it's a really small molecule. It's not a big so that it's not.
Oh, this summer with faculty and Discovery 2, I know there's working the NCAR education and outreach and NASA. I'm wondering to what extent Rogersfield is
You said the difficulty with the transition.
But that's a good point. So, and also, I think the folks out of Langley have been doing a lot of work with the Discover AQ, working with them, low schools, and really doing a formal education kind of component. Thanks. All right, so we're going to move on now to our session where we get to hear from our local, regional air quality management
votes. And so the first up is Paul Miller from the Northeast States Recording of Air Use Management, who's going to tell us or ask us what does the sign say about NOx controls or policy in the future.
One hand. This is gonna work. You can adjust it.
All right, well, I'm certainly not going to tell you folks anything. I will come up with things to ask. I hope that you're all I will make up and Danielle for the current meeting, 15 minutes walk from my house. The last one I didn't go to because it was in Houston. I work for a public state agency called the travel budget. So Danielle, I'm sure you could location travel budget. I'm going to give a quick overview of NESCOM. Many of you probably know us, but with this overview, I'm going to kind of explain why I'm not going to go a whole lot of detail about issues in the states, because there's a long list of folks who are here to talk to you who are from the states that and I need something to talk about. So I would digress. So NESCOM is a multi-state agency. We are a non-regulatory agency, but our membership are the state air quality agencies in these 8 Northeast states. We've been around for a long time. We're the first organization of our kind. We were organized in 1967 by the New England governors. We actually predate today. So we're an example of regional cooperation that's been going on for decades. Largely a reflection of pooling of state resources. Most of these states are quite small. And a reflection of just geography. We're kind of down in a lot of other sources. So the acid rain days and stuff around. And as an organization, we provide technical and policy support to our member state agencies. So states have spent, I'm going to focus on ozone, states have spent decades trying to deal with this. And states have made progress in reflection of the science, and the science results that we developed through the previous years. And we made great progress, but as we make progress as health science, the ozone standard becomes more stringent over time to better protect public health. So as we move forward in addressing the current ozone standard, new ozone standards are always somewhere in the way, and we have to figure out how to get to meet those too. It's been an interesting learning curve in how to deal with ozone. It's at times been a flat learning curve for many years. And then followed by some steep increases. And part of that flatness was very on in the early years. Ozone control strategies were pretty much exclusively focused on controls. And NOx controls were viewed as counterproductive. So-called NOx controls. So we spent years against those strategies for ozone. So in 1992, many of you know this, out came from the National Research Council report, Rethinking the Ozone Problem. Among its many findings, basically said, kind of disconcerting for state programs. Over 20 years of effort at that time, VOC emissions have been significantly underestimated for a number of reasons that are going into the model. Country. And then it's interesting, kind of meaning like this, it's almost exclusively not. So some people argue that from the two-part the other end, maybe we could find that that's something that we can develop further refining strategies. So one of the things that came out in the mid-90s is the first regional NOx program in the eastern United States, covering 20 states. This was done through a multi-state process. And a lot of input from stakeholders, including the scientific community, and ultimately came up with a plan to address largely power plant emissions, not in the states. went into effect in May 2003. This slide is what regulators look at when they're thinking about trends. Each row of the slide are the 3-year averages of 4 to 8 hour maximum ozone, essentially the max standard of the 3-year increments, at individual monitors, in this case, in the state of New York. I think list of monitor sites, but each row corresponds to an individual monitor state. If any of these shaded colors, red or orange, you can tell the difference, are monitors that exceeded the max, either the older 85 parts per billion max or the more recent 76 parts per billion max, during that 3-year period. And you can see, anyway, this arrow, that's the when not so-called started to the left, qualitatively. A lot of ozone problems, and to the right, along with the oxidol, a number of other measures going on as well, a number of other reductions, especially multiple sources, so it wasn't just all oxidol, and this is just a correlation, but we see progress and over time, and there seems to be a shift around the time of oxidol. So that's the current ozone standard. We're in line for maybe the ozone standard. EPA calling for a deadline to propose a potential new standard if appropriate. So I want to be clear that EPA is not required to issue. It's only required to decide whether it's going to issue. So it's proposed by December 1st of this year, and if it does revise, the final high court orders. So that's on their right. Deja vu all over again. This refers to KSAC. KSAC is the Clean Air Science Advisory Committee that advises EPA on where the health science is going, like various standards. In this case, the ozone standard. They came out with their 3 recommendations of June this year. Essentially, the same recommendation for the primary standard, the health-based standard. Which EPA at that time did not necessarily follow to the letter, and they applied. They also have a recommendation on the secondary standard, which is effect vegetation, much longer term standard rather than our basis, I think. So those things are re-recommended, essentially the same recommendations as last time. EPA did not follow those recommendations last time, and it's an open question whether they'll this time. So, with that as background, every time an ozone standard gets revised, how do the states deal with it? Well, first you start with the mission. States get, this is great science, and it informs a lot of what the states do. The states are really guided, directed by statutory deadlines. So the extent of the effort within the states on ozone is really focused on air quality modeling, demonstrate that they can obtain the standards within the statutory deadline, typically 3 to 5 years. And that's the time horizon. Spent a lot of time dealing with emissions inventory. There's a lot of discussion about the national emissions inventory and how states put information into that. I don't know what happens in translation, but a lot of states don't want what's in the national emissions inventory that's supposed to come from them. I don't know why that happens. There's a lot of back and forth over what's in the national emissions inventory and how states finesse that to their own states. Then they run the air quality models over and over again. Somebody, Jeff Underhill from New Hampshire, there's a lot about that. In which they assume various control strategies based on technology, available costs. They do consider costs maintained the same result, although they're not, costs aren't considered the same. And they keep squeezing the model to try to show pain everywhere that they're required to show pain. And then past history is like they haven't found enough reductions. So eventually they come up with across the board reductions in emissions, killing NOx. You're not exactly sure where they're going to come from, but they just cut everything they can and hope for it. So that's the extent of where the states are when it comes to ozone. So the questions that I came up with in that context, that maybe you can inform, and maybe the wrong questions, maybe they're not applicable to the kind of work that our capabilities are out there now, is how well do these air quality planning models really capture the role of strategy? Are they, I sometimes wonder, are they too insensitive? Are there so many cancellation errors built in the model that they become insensitive to changes like emissions inventories? Because in fact, you don't want the emissions inventories to change when you update them. You don't want them to change the results too much, because then you have to go through the other things. So sometimes I wonder if it's have kind of been, not intentional, I think, but developed over the years, almost insensitive to these changes in emissions that computers are not, so that their predictions don't figure it out. Second question, this goes back to the cost benefit. It's nonlinear. Have we, in the real world anyway, or even in the models, have you got over that ridge line, the hump, where you go from VOC sensitivity to NOx sensitivity? And I know that's too general question, very time of day, application, et cetera. But sort of more information on this VOC NOx potential trade-off, at least in those few urban areas, and then a policy question about day-to-day changes in NOx versus what has evolved with each ozone season program. And specifically, the NOx SIP call, its successor CARE, its maybe successor CASPER, and the successor to whatever that's going to do that you could. Now, these are all based on seasonal budgets. Reducing NOx emissions down to a budget across the entire season. But what goes on day to day within those budgets doesn't matter as long as you meet the overall seasonal budget. But those are episodes of the standard, short term. Are we missing something when we look at ozone season budget versus what happens on a day to day? So, my naive questions that maybe people here might find interesting or capable of looking at that can sort of test these models. Are there real experiments out there going on that can give an indication of how sensitive the models are to real reduction, real changes that are occurring, or that we think are going to occur? First is this Tier 3 sulfur gasoline rule, which I will describe shortly. High electric demand days, 5 days when electricity demand is high, so that the power plant emissions go up to meet that. And then something we're seeing under these seasonal budgets where power plants actually have selective catalytic reductions and reduce 90% of NOx emissions, turning off those controls because they don't need to run that under our season. Okay, so very quickly, Tier 3, in 2017 we're going to reduce sulfur in gasoline from 50 to 10 parts per million. Doesn't really matter about the sulfur, but the NOx emissions from mobile sources, gasoline passenger vehicles, could decrease almost immediately because of decreased sulfur poisoning catalysts. Is that going to be enough of a signal, especially in urban areas where the mobile sources dominate, that you might be able to see something from the ozone response and how models predicted or simulated that kind of thing? High electric demand days, once again, day-to-day emissions responding to increased demand. Can also be what's ozone does to the hottest. As an example, this is the old way we modeled power plant emissions in things like CMAQ or CAMEX. Power plant emissions, annual emissions, were then distributed across a monthly basis based on standard activity factor, and then within each of those months, it's distributed across weekday and weekend, and each day of the week, each day of June, all had the same emissions. Wednesday, all had the same emissions within that month. That's what it looked like that was going in the model. This is what it looks like when you look at the actual emissions from continuous emission monitoring systems on the power plant. So you get this kind of variability versus that kind of variability in the model. On a day-to-day basis, that's big. And while NOx emissions are totally going down about 20% of the total inventory, on the days that matter, that's going to be a much different distribution or impact. So we're missing also something on these days, things like distributed generation, small diesel, control sources. We don't know what they are, but they're really rapid. And then the power plants. Here's an example of some emission rates feed inputs, pounds per million BTU of power plants in Pennsylvania. On the left is 2003 and earlier. The emission rates were higher. 2003, Mexico came in, they went down. 2009, they all went back up. Control is still there, but they've come off. So we're making progress, but we have questions about our ability, or the model's ability to tell us where we're going, and then we have some policy questions about those shorter term, those days. And once again, those are my ideas.
Well, more of a comment than a question. Good job you did.
Well, you're not a member state, so I don't feel bad about that.
Well, same issue. Okay, a quick comment and a quick question. First of all, the variability on a day-to-day basis, whatever I see last year, did an analysis to find a penalty factor. Okay, why is there more ozone on hot days? And it turns out exactly to show there's more electricity demand on hot days than constantly higher. You take some reasonable approximations for the ozone production efficiency. A fair chunk of the ozone climate penalty factor is probably higher NOx emissions on hot days. Kind of embarrassing and boring, but that seems to be the reality. The question I have would be, is the response of tailpipe NOx emissions to low sulfur fuel, is that observed, or is that something that you go through loops and they think what happened?
I have no idea. It's based on some tailpipe lab studies of low sulfur gasoline. So projection.
Projection.
Yes.
Okay, thank you. And I'll just remind everyone that we have a panel discussion after the break. So we'll should be plenty of time to follow up on conversations regarding during our speakers' presentation. Okay, so next up is Ellen Burkhardt from the New York State Energy Research and Development Authority.
Okay. Well, thank you. I'm with an energy organization, a state-level energy R&D group, as opposed to an air quality planning group from DEC or one of the others. We look at energy technologies, which are constantly changing. We have a pretty strong R&D function as well as consumer incentive programs, and so we look at everything from power generation, building envelopes, vehicles, just a sampling of some of these activities. Some of these slides are pretty dated. The original hybrid buses, probably some natural gas-powered taxis, one of the early plug-ins when that was a new technology, and now it's widely available. We've repowered some ferries in New York Harbor. That's a point at which a lot of people can become exposed to an intense amount of diesel emissions. We needed to go to low sulfur diesel to accommodate some of the technologies there, new engines, new catalysts on the oxidation catalysts. And also something that's emerging now is high efficiency wood combustion. And this is this lower right hand corner is a company in Western New York that we've worked with for a few years. I work in the environmental group, but I'm within the Clean Energy Research and Market Development Program. We have a fairly large per state environmental monitoring program where we look at questions that have to do with informing energy policy decisions. So it needs to be relevant to energy and what we're doing. We support accountability studies through long-term monitoring. We look at health and ecosystems effects from various pollutants and changes in those pollutants, and support an environmental research capability to better address the critical problems facing the state. This is electrical generation by fuel type. You can see it's changed a lot, especially in the recent years. The base load is the nuclear and hydro. And then we have recent large increases in the use of natural gas for electricity generation. We have imports, but then we see a reduced amount of coal use and a reduced amount of petroleum use. Wind actually makes it on the graph in these recent years. And then there are other, and I'm not exactly sure what's in other. We have a couple of biomass-fired plants, but they're not very big. And all of this changes the emission profiles of those plants. As energy use changes and the fuels used to produce that electricity change. And then also heating is a major source of use of energy in New York, and that's seen dramatic change over the last few years. We've seen the price of home heating oil increase substantially. I think it's a tripling in the last decade. Propane has also gone up. At the same time, natural gas has come down, and anyone who can get on natural gas is usually opting to do so. In the areas where we don't have natural gas distribution networks, you see a large increase in heating with wood. This is generally, almost exclusively with old, existing, installed wood combustion, or even if they buy new wood combustion, largely the conventional technology in the U.S. is 20 or 30 years old. There are also some really egregious gross emitting units that are really not energy technologies, and we're trying to work with manufacturers to change that. And last year we also saw not only spiking in the price of oil and propane, but even difficulty in getting supply, which is creating a sort of a panic amongst people in the upcoming heating season to get an auxiliary or a backup secondary source of heating. And very often that's wood combustion. So environmental monitoring, evaluation, and protection focus on addresses many areas. I'm going to talk a little bit about air quality, but we do look at ecosystems, climate change, alternative energy. And I have a colleague that gets the great site visits. It's always someplace nice in good weather with critters. This is looking at acidification of lakes and actually the improvements to them. Also looking for biological indicators of recovery, but also looking at continued bioaccumulation of mercury in songbirds and loons, spiders even. We've had some pretty intense storms the last couple of years. Vermont also saw Hurricane Irene, or Tropical Storm Irene and Lee, and Hurricane Sandy. This is damage to infrastructure that was pretty dramatic and covered in the news. We look at alternative energy because there are also impacts to that. Some of it is during production of that technology. Some of it is while it's operational. Some of it is actually in use if it's a combustion system like wood. This is an advanced technology manufactured in Europe, this lower one, that's being tested at Brookhaven National Laboratory. I'll talk a little bit more about that because wood heating is really important in this part of the U.S., and we've seen great increases of it. In terms of air quality and health effects, we've supported many studies. We have several long-term sites that have been going on for, well, almost 20 years in some cases. Some early sites supported by ASERCO and EPA that we kind of took on 15 years ago or more. The SUNY Albany sites, original super sites in Queens at Whiteface Mountain, and also in Pinnacle State Park. We also have a long-term monitoring site in Rochester that has a nice collaboration with some health studies there. And when you have these long-term sites, you can look at changes, and we saw a lot of this yesterday, the reduction in sulfur dioxide measurements with the reduction in emissions. Similarly, changes in particle composition, maybe not the reduction in particle mass, but a change in the character of that particulate from being more sulfur and nitrogen rich to more organic rich. And so why is that happening? Is that a different chemical reaction now able to have gas to particle conversion? Are there different sources? And of course at this time we've also seen a lot of change in energy use. So we'll continue to see changes in energy use. We'll continue to see some things that are planned for reduction of SO2 and NOx. There'll be some controls on upwind sources. We're seeing repowering of coal-fired power plants in New York. And oil-fired plants that are capable of fuel switching with an economic dispatch to do so will. It takes a few hours to switch over to natural gas, but if it's advantageous, they'll use oil, they'll use natural gas. And that's generally a number 6 oil, so that's a sulfur-rich fuel. We have seen cleaner fuels, and this enables other technologies. Paul was talking about going to low sulfur gasoline. We've certainly seen the switch from ultra low sulfur diesel that enables the oxidation catalysts that are on the buses in New York City and many other places. And also, we've gone to ultra low sulfur home heating oil. This is the same fuel product, so it's now in the on-road, the off-road, and the home heating oil, which makes it easier for some in the distribution business. And what we love about ultra-low home heating oil is it enables us to bring in now condensing technologies into the market, so we can go from 85% Energy Star product up to 93% efficient on an annual basis for home heating oil. We see a lot more natural gas, a little more fill-in of the natural gas distribution system going on, and I mentioned the wood heating, a lot more renewable energy in terms of solar. We've seen some market changes in that the homeowner doesn't have to buy the panels, and I know a lot of other states do this too. They may be leasing out their roof space, so they're not taking a second mortgage, they're not taking a loan, they're renting their space, they're getting a benefit of cheaper electricity, and they feel very good about it being a renewable energy and have net metering on the grid. That's really, really important to the growth of solar. Energy efficiency, that's probably our favorite thing to do at NYSERDA. Use less. Use it more wisely. Look at the timing of when you use it. On those high electric demand days, we want to make sure that there's electricity in places that need it without turning on those peakers that are very high emitting sources. If we can manage with demand response, that's much better to do so. And so we have programs that encourage large warehouses of refrigerated and frozen, whatever, food goods or what have you, get that cranking in the morning. That's what I think they do. And then try and decrease load in the afternoon when everyone else needs it for the air conditioning. I think that's a simplification of that program. But using smart grids, I think we're going to see a lot more of that coming in the future. Coming soon, and I don't know too much about these programs, except the third one, but New York is going to go to a clean energy fund, and that's a move to market-based sustainable products and services. Our Secretary of Energy is actually the Secretary of Energy and Finance, and so they're very keen on market mechanisms to so that we don't continue to do rebates forever, that these things grow, the prices come out of them, and the consumer goes for them without being enticed beyond the first years to get over the early adoption. And then reforming the energy vision, which is more distributed energy resources, energy efficiency, and on-site clean energy generation. And we'll see what all this means. These are just recently announced in the news, and I think we'll see what those programs entail in time. And then Renewable Heat New York is something I've been involved in very heavily for, well, biomass heating for now, I don't know, 7 years. But the Renewable Heat New York was announced by Governor Cuomo in the state of the state. We're going to have a longer-term commitment to high efficiency and low emissions wood heating, and we're going to try and bring up that market more as an energy technology than driven by a low-cost fuel, where we'll have high efficiency, low emissions, some manufacturing in the U.S., some importing, partnering with European technologies to be manufactured here, and we have a domestic source of wood, as do the other New England states, and keep those costs within the state, within communities, and provide cost savings to the consumer. As part of that, we will have significant retirement of older, higher polluting technologies. So I guess before I wrap up, I wanted to sort of set the stage for some of the other speakers. There's a very wide range of technology performance in wood heating, from really, really egregious, inefficient technology to high efficiency technology. And this, oh, okay. This technology here is what's called a two-stage gasification technology. It is designed as an energy technology. We have gasification going on. The fuel is being converted from solid into gaseous, into an organic gas that can be burned. This is a low oxygen, low temperature for combustion situation in the upper chamber. That goes into the secondary combustion chamber where preheated oxygen-rich air comes in. You've got time, temperature, and turbulence for complete combustion. These units at steady state can achieve over 85% efficiency, which is a far cry from these technologies, which were measured at 22%. The better performing ones at 30% thermal efficiency, which is just simply not acceptable. This unit was lent to us by a company in New Hampshire, TARM USA, imports this Frohling boiler from Austria. They lent us that boiler and 2 thermal storage tanks to test. What one does is they burn that whole charge. If the house has met its call for heat, the rest of that energy is dumped into these large thermal storage tanks, and then when the thermostat calls for heat, the circulator just brings it into the house. And that is a much better way to manage the energy from these than having these systems idle down. So what's the difference in performance? I mentioned the difference in efficiency. This is probably this one's measured at 22%. This is a common call for heat for a house in upstate New York in January. The advanced outdoor wood boilers at 30% have a lot less pollution, a lot less particulate matter. The downdraft has a similar behavior unless you have a smart downdraft. The one I showed you has an oxygen sensor, variable speed blowers, control systems for optimizing combustion. We look at pellets, which are a much drier fuel, 5% moisture content that you can feed in as you need it. You get even better performance. And here's the baseline for us, an oil-fired boiler on the old number 2 oil, and then on ultra-low sulfur. And then my last slide is not only does the total PM significantly reduce from these technologies, the composition of that particulate matter is different as well. This is an advanced pellet boiler. They were trying to keep it at high load. There was a little bit of cycling going on. You can see this is the organic component. This is potassium. That's sulfate. This is unresolved, but it may be organic. But you can see for normal wood combustion, it's almost completely organic, very little inorganic. So we're getting far more complete combustion, and the particles are largely inorganic, as well as total less mass. And that's, I think, the end of my time.
So if someone has a quick question while we're changing speakers. Yeah.
How will you develop
Great, I don't know.
So I'm going to introduce our next speaker, who is Jeff Underhill from New Hampshire's Department of Environmental Services.
First off, I'd like to thank you for inviting the states in for a state perspective. Having access to a meeting like this where we can see what you're doing and vice versa, the research community to see what the state's needs are, I think is a great fertile ground for making sure that our efforts are on task and we're helping each other out. Budgetary times are just a little bit too slim to be able to waste our time. So again, thank you. My name is Jeff Underhill. I'm from the state of New Hampshire. I'm the chief scientist. Basically, anything that anybody else in my agency doesn't know how to deal with on a scientific perspective, I get stuck with it. I like doing puzzles. I like trying to figure out how things come together. Another task that I have, take off my New Hampshire hat, I'll put on my Ozone Transport Commission hat. I am the chair of the modeling committee. So when Paul Miller mentioned earlier that I run a lot of models, yes. We do that, and we do that for all the Northeast states, basically from Virginia right on up through Maine and westward to Pennsylvania. And we do that largely for ozone and for particle attainment purposes. So on my talk today, I'm going to spend a little bit of time, actually, I'm here to ask for help. You know, I'm trying to solve problems, and there's some problems that I just can't solve without having people that are smarter in some areas help me fix some of the issues. We spent a lot of time yesterday talking about satellite data, and satellite is a fantastic tool. You're looking down, but one thing that I think would really be helpful to the states is getting a better feel for how stuff moves up and down and where stuff actually lays in the vertical within the atmosphere. Because from New Hampshire, one of the big issues that we have moving forward is getting the vertical right and being able to forecast that vertical, what's coming in at different layers and how stuff mixes up and down in order for us to be able to attain ozone and for PM in the wintertime. These are our two issues that we really have in terms of the criteria air pollutants. I'm going to raise a question. Actually, I've introduced that, but now I'm going to spend the rest of my talk actually talking about some of the data that I have. So if you don't like seeing words on a screen, just about every other slide I have is full of pictures. This is taking a look back over the last 5 years by monitoring site within New Hampshire and the number of days that we exceeded the ozone standard, 75 parts per billion. The left couple of monitors here are essentially in the western, central, and northern parts of the state. But when we move to the southeastern portion of the state, all of a sudden things start happening. And there's a reason for that, and I'm going to go into it. But that's along our seacoast area. These other two problem spots are high elevation. And that gets into that vertical issue that I was mentioning before. The monitors that are right beside it are low elevation monitors. In this case, that's Nashua, New Hampshire. Yes, it is seeing some ozone, but nothing like what we see at Miller State Park, which is at 2,000 feet higher in elevation. Mount Washington Summit. Actually, yeah, Camp Dodge is the one that I was more interested in, but it doesn't really matter. They were both zeros anyway, so we're just not seeing the ozone at low levels, but it's all coming in aloft. Our problem spots in New Hampshire for ozone, summit of Mount Washington, summit of Packman-Adenoch, which is Miller State Park, and our seacoast. Taking a look at the topography of New Hampshire actually helps answer some of the questions. This area in the southeastern portion of the state is actually the area of the state that sees most of the transport coming up the East Coast. And it sort of blows across the low-level east, southeast of the mountains area of the state. So if it's coming up from New York City, it gets trapped by the mountains and sort of gets funneled in along there. We've got a couple monitors. Mount Washington's actually in the northern part of the state. And it offers a unique perspective of what's really coming in at high elevation. If you've ever been to Mount Washington, you get to the summit, you'd be hard-pressed to see a community from the summit of Mount Washington. It's just all mountains and it's all forest. There's not much by the way of local sources that could contribute to the ozone exceedances we see on Mount Washington. Packman-Adenoch. This is actually a very interesting site because it's up at about 2,000 feet. It's at the northern terminus of the low-level jet that blows air pollution up the seacoast. And it's within that southeastern portion of the state. It's right on the upwind portion of the state. And we did something a little bit unique here that we thought would help research and would help develop better tools in the future. We paired our NCORE sites. We actually have two NCORE sites. One is on the summit of Packman-Adenoch at 2,000 feet. Another one is just a handful of miles away in Londonderry, down on the lower level plateau. So it's probably at about 200, 300 feet in elevation. So we actually have a vertical component here with ongoing monitoring information that provides sort of a neat tool. If we actually start looking at how the data pairs on the high-low where we have sites, I'm going to start with Mount Washington. The top chart there is Mount Washington ozone data on a diurnal profile. So we're taking averaged ozone values for each hour of the day, and we're just averaging it across the season. The blue line on top is the summit. It's pretty much flatlined. This is the base, which starts off at much lower level ozone and actually winds up increasing during the day and then drops off again. Nice almost bell curve. The chart down below, same data, except for the fact that in this case we're only looking at the days that we had a high ozone at the summit. What we ended up seeing in this case, at the base it starts off quite low and sort of charges up to almost the level that we saw at the summit. Meanwhile, the summit, if there's any kind of detour in its flatline projection, it dips a little bit at the same time. Seemed to be suggesting that we're seeing some downward mixing, and that's being picked up at the base. There really aren't any local sources that are driving a heck of a lot at the base, so that would seem to make sense. This is just an example of a real episode that we had in 2002. Ozone starts at 70 parts per billion coming in, and at the base of the mountain it's actually starting quite low. We hit the daytime mixing, the base comes jumping up. Going into the next night, we set up another inversion, and the ozone just kept coming in at the high levels. It ended up peaking out at quite high levels and came back down again when we hit the daytime mixing the next day. And you can see how the base sort of fluctuated up and down in correspondence with the mixing. Pac-Monadnock, very similar type of pattern, except keep in mind this is actually at a lower elevation. So Pac-Monadnock is a nice tool for us to get some type of predictive level of where we might be at the lower level monitors later in the day. If we look at all the data, you can see that these other monitors actually sort of come up to what Pac-Monadnock Summit was saying all along. On the high ozone days, though, it's a little bit more of a scramble. There are some local emissions. There are some that are just upwind of our state that can actually continue to build during the course of the day. So on the high ozone days, just the level that's coming in is not going to be a real great predictor for us of just how high all these can be. Something else that happens here is even though the summit sometimes has higher ozone during the events, it can work around the other way. Stuff can get trapped below and it builds, and the summit actually can stay in the good low moderate ranges. Okay, NO2. We do measure NO2 at both the base and the summit of Pac-Monadnock. As you might expect, when you're at low levels, you see sort of this bimodal pattern that corresponds with rush hour. Cars are one of the largest sources of NOx in Nashua. But when we go up to the summit of the mountain, that bimodal pattern essentially disappears. So it's suggesting whatever is creating the NO2 is essentially coming from somewhere else. The timing, there's a little bit of an increase here towards the tail end of the day. I suppose you could backpedal, looking upwind, trying to do a calculation as to when and where that may have come in. Trajectories. This is one tool that we really like to use in New Hampshire to try to get a feel for where stuff was coming in. If we take a look at the trajectories at these low-level sites, most of the ozone was coming in from low levels up and down the corridor. Very clear pattern that we're seeing that east side of the mountains affecting this. One other thing I'm just going to point out here real quick, this is the Nashua plot. You can see most of the winds during high ozone is actually coming in from the southwest, very typical for our sites, but Nashua is right on the state line. Tacmonadnock, this is the mountaintop, 2,000 feet elevation. This is a little bit different. It's not quite as focused on that corridor. It's actually picking up emissions from more of a scattered area that includes the corridor, but also goes further west. So it's getting some fetch from across the mountains in some of the areas, more in the Midwest. You go to Mount Washington, and the picture is completely changing at this point. The corridor is almost not a player in this, but according to trajectory models, it's suggesting that most of our fetch here is actually coming from the Midwest. And it actually, I think that's just a pure how it worked out for this data, but there's quite a bit actually right here along the Ohio River Valley. So, do the models get it right? That, as I mentioned yesterday, we live and die by the models. We need the models to work correctly to help guide the states. This was a modeling exercise that was conducted by CAMX on our 2007 modeling platform data. Other modeling efforts seem to suggest that this modeling is reasonable. For Nashua, this is the site that's right on the Massachusetts border that showed all the high ozone coming in from the southwest. The model's still saying that 13% of this is coming from New Hampshire. Okay, but I'm still calling that reasonable. It's suggesting that other states within the ozone transport region are about 46%, and beyond that's about 6%. Well, we've got this big chunk here of boundary conditions. We're not really sure what goes into the boundary conditions. Some of it's global, some of it's US. That's why I was asking the questions yesterday about boundary conditions. Mount Washington, little different picture here. It's saying about 44% is coming in from the boundary. Okay, that's somewhat believable, but I just showed trajectories before that showed everything sort of milling around in the Midwest within the modeling domain. So I've got a disconnect here that I can't quite figure out. Home state about 2%, okay, reasonable, and other states within the region account for 40-some% of what's remaining. If we look at Camp Dodge, right at the base of Mount Washington, it's almost a clone of the summit of Mount Washington. And I can't decide if I like that answer or not. I suppose if we're getting downwash from the summit, then the sources should be very similar to what the summit's getting. That's my logic trying to work on this. So I'm going to say, okay, maybe that's right, but I still don't like this 44%. I'm not sure if I believe it. Let's take a look at model performance. These are model performance statistics that were for our CMAQ modeling on the 2007 modeling platform. I know you can't see the dots, so let me zoom in here a little bit on the Mount Washington area. The purple area underneath is actually the summit. The two yellowish blobs are low-level monitors that just happen to be in that area. So what we're seeing is we're seeing a significant low bias at the summit, and we're seeing a significant high bias at the base. Okay, that's saying that we may have some vertical mixing issues with that, but let's look at some other statistics. Mean error and correlation coefficient. This correlation coefficient really grabs me because we're talking about correlation coefficients that are down around 0.4, 0.5, when the whole rest of the domain is up at 0.8, 0.9. If there's an issue with the model, there's something going on with this vertical in the mountainous terrain. Did I mention, if we become non-attainment for ozone in the upcoming months, it's likely to be these mountaintops. We're going to have to put a plan together that's going to bring us into attainment. And yet, I don't know if I can rely on the models to tell me exactly what the problem is. But in the spirit of modeling, we've often learned that if you don't like the answers of one model, you build another one. So this is actually working with EPA. We've taken a bunch of their information and we're developing a new modeling platform for our region. And this is very preliminary, but we're still seeing some of the same low biases at the summit of Mount Washington with this platform. Overall, things are improving, but we're still seeing some issues. Just touching real quick here on the PM issue. The PM issue is a real issue for New Hampshire. I think Rich Pro may or may not mention PM in his state because that's about the only problem Vermont has, right? But we need to forecast PM. We have a problem area within the state in the southwestern portion where there's a whole lot of wood burning that takes place. In order for us to exceed the standard, and we do exceed the standard for PM, we need a regional punch of PM coming in from other places, and then we need a thermal inversion to set up to trap local emissions. So we're trapping what's transporting in, and then we're building on top of it with local emissions. So we need to get a feel for whether or not various forecasting tools are right. We cannot run a regional model because it's just not going to get all those emissions right. It doesn't even come close to helping us forecast. So we use other tools, and predicting PM is a bit more of an art than it is a science still at this point. But this is a picture of the problem that we have in this community. An inversion sets up, it traps the emissions coming in regionally, and then we just smoke out the valley here underneath the inversion. Meantime, everything that came in regionally sort of blew away overnight because it could. But it's sort of a nice graphic picture here. You can see the mountains in the background because they're still in the clear. So I'm going to stop there. I'd be happy to take questions and take it from there.
I think that you raised a lot of exciting information for the panel discussion, and I suspect there's many questions in the audience, but I think we at least decided around the next speaker and see the Thank you, Zach.
Thank you for saving me from the questions.
So next up we have Rich Pro and Evan Oswald from the Vermont Department of Environmental Conservation.
This is the view from Vermont, in the upper panel, looking from the city of Burlington, where I live, and where Evan Oswald lives, across Lake Champlain into the Adirondacks of New York. Through the lens of one of George Allen's cameras, that is one of the terrific services that NESCOM provides to its member states, automatic images snapped every 15 minutes and refreshed. And the lower panel is the same idea, trying to see the Adirondacks through higher concentrations of particulate matter. I ended up, I borrowed this from a talk that I gave almost exactly 7 years ago to the Ozone Transport Commission, but was interested at that time in hearing about the pending revisions to the ozone maps. And everybody was excited because ASAC was recommending lowering the primary standard to the range of 60 to 70 ppb and establishing a new secondary W126 seasonal summation standard for sensitive vegetation. So here we go again. And I found this picture, by the way, just about a week before that meeting 7 years ago, and it marked that not only were we exceeding the PM standard, we were also exceeding the old 0.08 ppm ozone standard at the same day, at the same locations. The first time we'd done that in the preceding several decades. In fact, we haven't done that again since. Which kind of is our story in Vermont. We've led this charmed existence. Back in the late 70s, early 80s, we would have exceeded the 1997 ozone standard had it been in place at the time, but at the time it came into place, our concentrations had lowered safely below that level, and however, we would have exceeded the 2008 ozone standard. Had that been in place by the time that got enacted. So it's almost like the definition of the map should be just a little bit higher than whatever Vermont is. Which is why EPA couldn't take ASAC's advice last time, because it would have put us right on the edge. But now it's okay. It's okay to go lower, I think, but maybe not all the way down. So not being in non-attainment, you know, you got to be interested in something. So one of the things I'm really kind of fascinated by and have been for years is this spring thing, the spring ozone. These are diurnal average cycles over the last 10 years at just some selected sites. We have a pointer. Down in the more congested part of the urban corridor, we get a very distinct midsummer peaking temperature, sunlight peaking pattern, higher peak. But as we move up sort of to the middle of the New England region, this peak broadens out. It's a little bit lower, but it's broader. And then up into my neck of the woods, all of a sudden, these are averages over about the last 10 years of the daily max ozone. We get this spring maximum and so forth. So here's the same idea from one of our sites. If we look at progressively lower and lower thresholds, and again, for the high concentration days, go back. For the higher concentration days, it's a broader peak, but as we look to lower and lower thresholds, this spring thing becomes more important. So I was really kind of excited to see yesterday that the future may further emphasize that there is a year, a lot of different things are going on at that time. So I'd like to nominate that as something of interest to the region, at least from the perspective of the people of green state in time. PM, we're a little bit closer to the standard, living more dangerously, especially for us, it's the 24-hour standard that we bumped right up against the edge of. And particularly at one of our sites in Rutland, Vermont, which is in a deep mountain valley like New Hampshire. This is from the past winter. We had a colder than normal winter. We also had a higher frequency of inversion events. A lot of freezing rain, warm air aloft, cold air underneath. We started to worry, were we going to be in danger of exceeding the new annual standard over this past winter. This change, by the way, this summer peak, this used to be, of course, the big peak, the big Salt Lake peak with a smaller winter tail. This is how things have changed over time, but this is an issue of concern to us. And not only is it a big diurnal fluctuation, a seasonal fluctuation, but diurnally as well. Here, 3 days last winter when we were safely below the level of the standard on the 24-hour average, but peak hourly concentrations are up to 2 to 3 times higher than the standard. So this is, by the way, this is a bare forecast these days. Really difficult to get these events right. It's also difficult to know what's the right health message to give people, especially when in the middle of the day, when they're most active outside, that's the clean part. Do you warn them, or how do you, what's the message, and so forth. So developing a better understanding of that, better ability to forecast it would be really helpful. Occasionally we get forest fire impacts. This one happened on Memorial Day 4 years ago. We didn't forecast it, by the way. We got it wrong. However, to the credit of the NOAA smoke model, we did a really good job on that event. Our forecaster wasn't paying attention at the time. It was a holiday weekend. I woke up, smelled smoke. I pulled our monitors. Our data acquisition system was down. I had no data. I called the commissioner. I said, we got to call a health advisor. He said, what are the concentrations? I don't know. Could have been worse because the preceding day was the day of the Vermont Queen City Marathon, the biggest sporting event in Vermont. We would have had to require the call off the marathon that happened earlier. So this happens occasionally for us. So my wish list includes things like this, some better forecast abilities for things like forecast forest fire impacts, as well as ozone events on PM, as well as ozone. I mean, winter stagnation inversion events, summer and spring ozone events. I also put in the hindcast concept. What I mean by that is a lot of these great forecast tools that you make for us are accessible in real time, but sometimes you want to go back and look at that event, so rediscover it from another perspective. Archival of that information is always helpful. We need better sub-daily health advisory metrics and health messaging. For the short-term extreme concentrations, I know the Canadians have an air quality health index, which is what, 3 or 4 hour average that can be reported in near real time and it's based on multiple. We could really use something like that. We need better, it's another thing on my wish list, better science policy guidance on either the co-benefits or trade-offs between some of the climate-forcing pollutants versus criteria pollutants versus hazardous air pollutants. Sometimes we're forced to choose amongst the 3 of these kinds of things, and we could use better guidance on that. Better spatial coverage for these various pollutants in unmonitored locations would be really helpful to us. You know, we know that we've had high ozone, like Jeff Underhill does, for example, on top of our mountains, so on and so forth. I put in that brown carbon concept along with black carbon. I'm not sure that's the right term, but we know that wood smoke is absorbent in the shorter wavelengths, and it's typically considered to be a scattering kind of a pollutant, but is it all scattering, and how much of that is really absorbing? And when you think of wood smoke over white snow, what are the common implications? Better remote sensing, more models to improve the accuracy and spatial resolution and meteorological variables. Jeff has covered that really well. And finally, a better understanding of past and future influences of changing climate on timing, frequency, severity, and so forth. Not only the extreme summer ozone events, but intermittent events as well, which leads me to why we're glad to be working with Evan Oswald to just take over.
Thanks, Rich. Yes, so I'm in Vermont from the University of Michigan. I graduated not too long ago, and Leslie Ann, including Drew is the state climatologist in Vermont, and she got me kind of over there with funding from people that work in the forest, people that work in public health, air quality people, and we put together. So we kind of started saying, let's work with some of the air quality people here. And so there's a figure that Rich showed me kind of right off the bat that had a little bit to do with year-to-year variability in characterizing the seasons with respect to how much overages we have in the threshold, the ozone. So I'm on a climate background. So I started thinking really in the meteorological sense and in the climate sense. So I wanted to take a lot of monitors and take a look to see what the relationship was with meteorology that happened. There's a lot of different literature, a lot of studies that have linked ozone to different weather. But it seemed like most of the time they were trying to remove the weather effect as opposed to maybe looking at the processes of what was exactly happening, and then flip that on its head and use those models, those statistical models, to build future projections to get you some kind of better feeling about what's going to come down the pipe, at least with respect to climate change. And then also, I noticed that there wasn't a whole lot of climate oscillation work. Like Yoon yesterday talked about El Nino with folding events and how that has a lot to do with that source of ozone. And so it seems like climate oscillation work has a little bit could really help us out. So anyway, my focus region is the Northeast from 1993 till 2012. I grabbed a bunch of AQS data through datafed.net, which is a good tool. And my focus is on the high end of the ozone distribution, so as opposed to the baseline. And I'm just looking at the ozone monitoring season itself. Just to quickly show my stations that I'm using in a 20-year average sense. This is the percent of the monitoring season each year that is in exceedance of the 65 ppb threshold. And basically that's what I was looking at. I was looking at actual years and kind of just aggregate the whole season and saying what percentage of my season was over the threshold. And you can kind of see a little what Jeff was talking about earlier. And that you kind of have much more ozone there close to the ocean, and that rides up through parts of New Hampshire, Massachusetts, even up to Maine maybe. But when we get up north towards Underhill, Whiteface Mountain, and yeah, you get quite a bit less. As you can see, there's only 1% season maybe on average. So these are all my stations with the time series. And some of the things that I like to think about here is, so I have these 3 different colors, yellow, green, and red. These are kind of parts of my distribution here with the water to the west and then to the northeast. And you can see that they have differences as far as in general, closer to land a bit higher. But also, the kind of the confusion here is interesting, in my opinion, is that year-to-year variability isn't the same at all the stations. They're not all coherent as far as that. So there must be, in some ways, some different drivers that happen at each different station. And lastly, you can see obviously that there's a trend and there's interannual variability. So there's got to be a lot of players going on here, and that's the kind of stuff that I was really curious about. So I was actually kind of thinking that I would start with a lot of metrics and try to boil it down and kind of just do a lot of exploring and looking at the processes. And so I actually break the metrics that I'm predicting into 4 different types. One is land surface climate, so your temperature, your dew point, how much sun you have. And I break it up into a local and to a regional scale. Airflow type, there's a lot of work with the OTAG where it shows how much transportation is important in this region. So I've been every day by wind flow type, high wind, low wind, with the direction. There's also been a bit of work with what I call more weather phenomena, so stagnation events, frontal passages, and then the last one was teleconnection. So that's like El Nino is the famous one, but there's a whole bunch of them that happen, and these are a little bit more important as far as informing global climate model that you might want to use going forward. And of course, we have to include the pollution trends. Because they're so dominant that you really don't see a lot of signals. So over the 83 stations I have, I made a box plot of the correlation coefficients with the year-to-year variability in the amount of the season that's over the 68 ppb threshold. And what you can see here is that the top orange and the pink, those are regional, or those are surface climate, temperature, dew point. In the green, which is kind of in the middle there, those are our weather. So stagnation events, frontal passages. And then we have in the blue, we have some of those air. It's basically just predicting by how the airflow that summer, where we're going to have a lot of ozone or not. And then the black ones are oscillations with that concentration there. And basically, so as I said earlier, I wanted to kind of look with global climate model data going into the future, so to kind of drive this model. And so that really only allows me to use those variables that I could use. And the thing is that when I use those, I can get about 50 to 95% of the variability explained. If I'm just using like stepwise regression to kind of pick the predictive variables and then use, it kind of changes from station to station, but it's almost always you're going to use the emissions. And temperature and radiation seem pretty important. And last one, here's the last one I have here is that when I just use a teleconnection oscillation, so like Arctic oscillation, field oscillation, North Atlantic, you hear these from time to time. The thing is that these are pretty important, and when you use global climate models to look into the future, a lot of global climate models don't incorporate or don't do well representing these oscillations. So when you're thinking about moving forward with picking a global climate model, you might want to try to pick one that reproduces these oscillations that are important to our problem. And while they're not nearly as important as Q concentrations, they're still probably pretty important. They explain somewhere between 25 and 75% variability, as long as I also have solutions in there. And it's kind of just going to leave this slide here. Thanks for the question.
We'll move on to our next speaker, who is Keith from the Massachusetts Department of Environmental.
Awesome. How do I advance? Okay, great. Thank you for having me today. My name is Glenn Keith. I'm a Deputy Director in our Air and Climate Programs at Mass DEP. Christine Kirby, who was on the agenda, couldn't make it, so I've come. And I appreciate the presentations from my fellow states and from NESCOM going before me. I don't have real specific research questions or needs because I'm not much of a science guy. But when I do have science questions, I usually call people like Jeff or Paul or Rich. And it really speaks to the collaboration that the states have, where certain states have certain strengths, and we rely on each other for our various needs. So what I do want to touch on are some of the issues that we're dealing with in Massachusetts that are maybe more routine, but kind of our bread and butter work that may be of interest to you all. So as you've heard, ozone has been one of the key challenges for all of the states in the Northeast, and in particular for Massachusetts. It's been the one that we've wrestled with the most. We were designated as non-attainment, serious non-attainment with the 1 hour standard. Then when the 1997 8-hour standard came out, we were designated as moderate non-attainment. We're still technically designated moderate non-attainment. However, a lot of the pollution programs, both within Massachusetts as well as regionally, have really led to a lot of reductions and significantly improved the air quality. I think Paul's slide earlier showed some of that. So that today, Massachusetts, for the 2008 8-hour ozone standard, 75 parts per billion, we are designated attainment pretty much statewide except for Dukes County, which is essentially Martha's Vineyard and some other islands in that area. And that was based on the Wampanoag Indian tribe has a tribal monitor on Martha's Vineyard, and Aquinnah, and that's the monitor that put us into marginal non-attainment. So here's a map currently of the 8-hour ozone non-attainment areas in New England. And you can see Connecticut has some non-attainment areas. Most of New England is in attainment, and right here you can see Martha's Vineyard in the blue. There's Dukes County with some of the Elizabeth Island chain right there. But the rest of Massachusetts meets the standard at this point. Interestingly, we just put on our website our 2013 annual air quality report. Based on the most recent 3 years of data, Dukes County does actually meet the standard. So we're still marginal on attainment, but it does. However, we're not out of the woods yet because we still have the ozone transport issue. And we have a monitor in Fall River that we put in 2 years ago. And just looking at 2 years of data for Fall River, that monitor would be violating. So depending on next summer, if we get another bad year at Fall River, we'll have a violating monitor because you need the 3 years. So we'll see how this summer goes. So far, no ozone exceedances. Overall, within Massachusetts, our whole inventory of NOx emissions and VOC emissions, which are ozone precursors, have gone way down. In particular, what this slide shows is also some of the sources that are subject to our NOx budget trading program. You can see how the various caps we have. This was the first NOx budget trading program cap, and the NOx SIP call, and this is the CARE EPA rule that we have, and you can see our sources for NOx have been well under the caps. A lot of this was driven partly by the caps and the NOx budget trading programs, but also due to the switch from oil and coal for electricity generation to natural gas. We used to burn a lot more oil in Massachusetts. That's almost non-existent now, except for sometimes in the winter, and coal is on its way out. We're down to 2 coal plants that are left, Brayton Point, which they've announced they're closing in 2017, and Mount Tom Station, which is a smaller coal plant in western Massachusetts. And they recently announced, at least in the press, that they're closing this October. So, you know, Massachusetts will have no coal plants in the future, and we're highly dependent on natural gas, but also, fortunately, renewables as well. So what these reductions have led to is obviously a reduction in the number of unhealthy ozone days that we see in Massachusetts. And you can see, and this is all, the past years are all geared toward 75 ppm, even though that wasn't in place. But you can see there's been a lot of improvement all the way to 2013, this most recent year last summer. We only had 6 unhealthy ozone days for the ozone season. So there's been a lot of improvement due to, you know, emission reduction within Massachusetts, but also regionally. So the air is pretty good in Massachusetts. Maybe it's blowing over us and going up to Mount Washington. But we're not out of the woods, as I said. We do have transport issues, and as you know, EPA is on schedule to publish, likely publish a new lower ozone standard in 2015, anywhere between 60 and 70 ppm, if you look at KSAC's recommendations. So that could put Massachusetts back into non-attainment. And here's an example of, Massachusetts basically has 2 patterns of ozone transport affecting us, depending on the wind direction. This is an example of westerly transport. And you can see this is where we get very high levels along the south coast of Massachusetts, Martha's Vineyard, Fall River, Fairhaven, Truro, whereas the rest of Massachusetts is generally cleaner. And then when we get through southwesterly transport up the corridor here, we get a lot of the highest ozone in central and western Massachusetts. Chicopee, Ware monitors might be up, whereas you see on Cape Cod, it generally remains cleaner. So this is the pattern that we're seeing, and again, if we get a lower ozone standard, we're going to have to address an ozone SIP. Some of the things, before I get to that, we're doing to address ozone is Massachusetts is a member of the Ozone Transport Commission, so we're collaborating with other states. We've been advocating for national rules, like the transport rules, like the Tier 3 rule that Paul mentioned earlier that has a big NOx benefit. There's also been a subgroup of states that have taken action to address ozone by filing what's called a 176A petition with EPA, trying to expand the ozone transport region, which would bring additional controls to other states in the Midwest. And so that's pending with EPA. So there are those actions that are going on, and we're involved in a technical collaborative with some of the upland states in the Midwest and Southwest, trying to see about if there can be consensus among the states in solving some of the ozone problems. Some of the other recent air quality issues we've been dealing with, lead. The 2008 lead standard was lowered from 1.5 to 0.15 micrograms per cubic meter. EPA's rule required that lead monitors be established at 15 general aviation airports throughout this nation, including Nantucket Memorial Airport on Nantucket. So we had to set up a monitor out there, which is a challenge when you're trying to set up and operate a monitor on an island. But the airport was very cooperative. We ended up having airport employees actually taking the samples and FedExing them back to us, so it worked out. But we did a one-year study, and it turned out that the levels were well below the standard, less than 50% of the standard, so we were able to end that monitor and take it apart after 1 year of study. And this is just a picture of it. It was 2 co-located monitors. This was based on a total suspended particulate TSP method for lead. It was interesting, I was looking on Google Maps yesterday. I wanted to get a shot of Martha's Vineyard, and you could actually see this monitoring station on the airport, even though it's not there today. But I couldn't figure out how to get that off Google Maps. So it's there. See if you can find it. It's in the northeast corner at the end of a road near the runways. Another interesting thing we've had to deal with is the updated NAAQS for NO2. In 2010, they established a 1-hour NO2 standard of 100 parts per billion, and Massachusetts was required to establish a near-road monitoring site, which is the first one we did. We have one in Boston, and that began operating in June of 2013, and so we've got about a year's worth of data, and pretty much so far the levels are well below the standard. Here's a picture of it. It's on the Southeast Expressway. If you take the red line south, right after you come out of the tunnel, before you get to JFK UMass, if you look to the right, you'll see it. It's right there. And there's basically 6 lanes of traffic that's usually congested, and so that's where it's situated. But we're not seeing high NO2 levels. We have also put in PM monitoring, CO monitoring, carbon monoxide, and black carbon as well to make use of this site. Another pollutant, SO2, 2010, EPA published the new NAAQS. They established the 1-hour SO2 standard of 75 parts per billion. This was a little more complicated to deal with. We have 6 SO2 monitors throughout the state. They all show we're well below the standard. However, EPA proposed a combination of monitoring as well as modeling of large sources of SO2. That proposal isn't finalized yet, but EPA showed a lot of interest in particular Brayton Point. They were taking some enforcement actions. And Sierra Club was also involved and hired a consultant to do their own modeling for Mount Tom, which is the other coal plant. They did that not only in Massachusetts, but in other states. So we certainly had to respond to that. And so Massachusetts did request modeling from both Brayton Point and Mount Tom for the SO2. Part of what precipitated the modeling for Brayton Point was our Fall River monitor did show some fairly high levels. So this is data from our Fall River monitor, and you can see that we're getting some levels that were above the new 75 parts per billion standard. This was 2010, 2011. And so what EPA did, this is an EPA slide from one of their presentations, just taking a look at, I think, this data point, looking at a 6-hour back trajectory from Fall River, and it goes right up to the Brayton Point power plant, no surprise there. And then they did a bunch of forward trajectories. Here's Brayton Point, here's our Fall River monitor, and you can see, and for all of those peaks, you get the same pattern. So it was clearly the power plant affecting the monitor. Since this time, EPA has entered into, and Brayton Point have a consent decree where they're running their controls all the time now on SO2, so their levels are way down, and this issue has pretty much gone away in terms of the monitoring. Some of the other issues we're dealing with, certainly air toxics and wood smoke. Ambient concentrations have been decreasing. We do monitor for air toxics. We have a trend site in Boston. We do also in Lynn. We do some in Chicopee. And, but there are still some unhealthy levels there. A lot of the air toxics issues tend to be having a localized impact and often an environmental justice component. We've had some efforts where we've gone into communities like Springfield and tried to go in and find various sources of not only air toxics but other things that affect quality of life and address those. We've had a lot of successful diesel emissions reductions. We've been able to get controls on almost all the school buses in Massachusetts. We've addressed, through grant money, and also MBTA has done a lot with their diesel reductions. And wood smoke is a growing concern. I don't think we have the same problem that you see in Vermont and New Hampshire because there's not as much wood burning, but in particular in Western Mass, we do get higher levels of PM even though we attain the standard, and there's some wood burning. But again, we've been trying to address that. We've had some successful wood change-out programs that have gone well. The last thing I want to mention is climate change. That seems to be one of the key drivers in Massachusetts. Today, we recognize the impacts on Massachusetts as well as globally. And we do have a clean energy and climate plan that has a goal of reducing greenhouse gas emissions 25% below 1990 levels by 2020. And currently, oops, how did I do that? Get a wrong button. Okay. So you can see our actual emissions are already well on target. This is the plan, business as usual. These are the reductions we were expected to get from various sectors. And if you read the press in Massachusetts, you see clean energy is really big. There's lots of renewals. We have state laws in place, Green Communities Act, Global Warming Solutions Act, that are really institutionalized energy efficiency, renewables, and so forth. And you've also seen the electricity fleet. We're a member of RGGI, and so I don't know why that does that, but we're a member of RGGI, and so our greenhouse gas emissions from our electricity producing facilities has gone way down as well. And so we've been also very engaged in the 111D, the carbon rule that EPA has proposed, and been advocating for allowing, maybe that's the end. I thought I had a slide on RGGI, but our greenhouse gas emissions have gone way down, and we've been advocating that under the EPA's carbon rule for this flexibility to use things like cap and trade, which Massachusetts is involved in. Thank you very much. Sorry about that.
We launched our climate talk, the carbon rule for providers and companies climate management.
I'm Barbara Moore from the Island Department of Management. I felt most of what I was going to say has already been said, so that's good. I try and make it. We have, for a small state, I think, a number of air monitoring sites every operating now, including the New York site that just began operating in Providence, April. We monitor all the criteria pollutants, also ozone precursors and the toxic properties. In general, criteria pollutants, except for ozone, more compliant with the national air quality standards, and in general, the levels, danger levels, are improving with time. And in some cases, we've seen some pretty significant differences from what I expected, particularly urban, rural, whether that in your source. I just put the record this is trends of carbon monoxide, and nitrogen dioxide, sulfur dioxide, is actually really kind of tanking lately because of the stripping the gas, a lot of the companies stripping gas in a lot of the large boilers and then also low sulfur fuel. And to comply with the standards that are which standards and players there. For the top, fish curve is as such, it's not on your website, but it is actually near the highlight system by 95. And so it'll be interesting to see what you see on your website. So the New York site is located just 5 meters from the highway. It's in the kind of the most congested and the most confusing traffic in Rhode Island. They're on 95 and Providence, or even long. Just in the preliminary, kind of looking quickly at the data for the last 2 months. See how CO2 are all a bit higher here in the sites, but we don't think they're mileage anything the rest of the course. We expect the to particularly be higher in the winter when the engines cannot function as well. And I think we do have some concern that if we could show violations, what would that mean in terms of human area, or even if you don't show a violation, so the fact that we're seeing higher levels in those areas, what does that mean? Say if a implications in terms of how many people are affected and how things are about the time. So the sort of spatial variation is really important to us. And so I think that that's something that we see as a, you know, as a way that satellite data might help us help inform those kinds of issues. This is just a time series from the first 3 months, maybe 2.5 months of data. That's the maximum data allowed to, and the yellow green kind of this thing sites and the other two sites. So almost every data mentioned now is taken higher. This is not very much data. So you see it. Ozone levels are definitely decreasing as we are here. This goes from 1978 to 2013, going down to 3 hours and values. But ozone is still a problem. As Glenn showed, we're designated as contaminant, but we're actually monitoring that. We're designated based on 2009, 2011 modeling data, but that was like the only year that we were actually in it. We were monitoring before that, and here subsequent, 2 subsequent 3-year data periods we have been again. EPA is not to say they now they're not going to redesignate us or any of the other community areas that this is true of. This 2009 is actually very low ozone summer, so there were a number of areas that were designated designated as clean in our modern. However, when this is completely separately whatever that story is. And this just shows that we're the dash line is the 7,000 touch per bird, and then with that one But 13 is actually a good ozone year for a lot of states, including a lot of states. I mean, the Atlantic area that have very high ozone levels. Not so much for the Western Central Rhode Island. This is looking at the monitors that have the most violations in the year. Something area that is 2011 in purple, 2012 in red, and 2013 in white. First one is Maryland. They had 2011, 2012 a lot of violations. 2013 a lot fewer. Something with Delaware, Connecticut, and Rhode Island had a different pattern. Obviously, Rhode Island in general has been better than. Considerably better than the designated metric, but last year not the case. This is just kind of a typical pattern of what we're generally seeing when we get that ozone release. Generally, it's bad, kind of in a big swatch of the area. This was in a high day of 2012. We had a 97 particularly hour level at our American monitor, which I know the beach, and that's where we go. So it's not a good place to have levels. And this is just a factory and shows that area that was coming kind of up in the Long Island area. This, however, was a high grade in 2015, and there were very few grades that were violating that day. In 93, this was similar kind of pattern for the red, which is the one that's and I don't think we really know why we're seeing sort of a different pattern now than we had previously. Some having problems around the states aren't. So that's another area that we would, anything that can help inform that would be is sort of superimposed on industrial or commercial or, high mobile source areas, so there's a lot of, kind of open space. So we get called up to do special studies. We've done in the last few years of inquiries, construction sites, industrial sources, recycling sites, demolition across the airport. This is really important because most people, what their exposure is really most dependent on what's in the immediate vicinity. I mean, ozone is important in a global way. Always reduces the point of your impacts from happening. Ozone is important. But in general, those knowledge sites are not impacted by the localized sources. Most people, their main concern is whatever's happening with the neighborhood. This is just an example of something that's been doing in the last few months. School is located next to a major construction site. These black carbon levels, and the yellowish, this black carbon at that site is right immediately outside the school. And the other ones are fixed black carbon monitors. So every time construction is in place for large peaks, you look at average over time, it's that not a clean out the times of the peak happen to be outside. Right at those times, it's so good it goes. And this just shows a day when the wind doesn't download and not work on it. And this is a day that there was no construction. And this is just something for the study that we've done down here before. So complicated to understand just because this showing the particle counts depending on wind direction. So these are the different sites, and basically what it shows is that each site has its down window the airport, the particle counts were considerably higher than they were at other sites. So this is obviously considered completely different vicinity of the airport. So the biggest limitations that we see in doing these studies are kind of control issues where lots of times we're limited to doing, and sometimes we can use continuous monitors for some images for some areas we can only use intermittent measurements, the limited number or the time we can do them. Whenever we do it, if we don't see something that people are convinced that there's a problem, they're saying that, there's no yesterday or tomorrow, or we can catch it right. And then of course the spatial issues, did we actually capture this location, or they'll have questions like, well, I knew the playground to know the area, or something better or worse, and you kind of limited. So anything that, again, that could be done that could kind of show either temporal or spatial variation that might inform policy and specific
Yeah, so thank you very much to all the speakers this morning. We're just going to have a 10-minute break. Let's really keep it short so that we can have our panel discussion with our speakers this morning. And then after the break, let's move break for lunch. We'll have food for so people here. And for the speakers, if you can sit at the front, have a break.
ask for help. I'm overwhelmed already because I appreciate the responses that I've gotten this quickly. We're still at the meeting and I'm already getting responses. Olaf and Brad in particular have stepped forward and offered me some insights. Yes, we have been running a 12-kilometer grid model. The vertical layering is probably not everything that it should be. The model state has been put together for state and purposes in hard to reach urban locations as opposed to these remote mountaintop areas. We are taking a look at tighter resolution. I do think that we're likely to put in a 4-kilometer grid over most of the entire Northeast through our next round of modeling. I'm going to make a push based on the information that I received at this meeting to improve the vertical resolution. I'm going to take a look at some of the tools that Brad has suggested that we might take a look at to help improve what may actually be coming in from other angles that we haven't really considered properly at this point. Being a state, though, we're also limited by EPA guidance. EPA really does not want to put out a guidance unless we know that this is going to be a step forward and that we've troubleshot the information. I'm going to speak a little bit for Brett. Mr. Golwick up there with in terms of how guidance comes out, but we do have to follow the rules or at least make a very good case for why we're not following guidance in terms of development. And so, thank you to those that have provided some feedback, and I welcome more as well. But we do continue to have some issues. I wanted to put those suggestions forward to let you know that I've received them and to build on that in terms of additional feedback. If you think those are the suggestions that will help us improve model performance or at least incrementally take a step in that direction, that's welcome feedback. If you have some other ideas, I'd love to hear it. Did I touch on all your topics?
Yeah, I'd like to hear from you. Comments from the audience, suggestions. So there's some, yeah.
Maybe just one comment on the high elevation sites. I guess some of the work that we've done in the past is the fact that you almost have to design the kind of cavity up to the hill, because what happens is the stable boundary layer, especially on the side of the hill, would never form. But actually, with the drainage flows and stuff like that, you can continue to bring ozone down off. And so I think maybe the main thing is you show the diurnal profiles where you really don't get to the typical diurnal profile of high latitude, high altitude. Model, I guess if you actually look at the model, it just replicate those sort of same time series. If you don't see it, you may not be resolving that. Right.
Yeah, and all I have to go with are the basic model performance stats that I showed you. So the correlation coefficient suggests to me that the data is jumping all over the place in terms of actually matching it.
Right. Yeah, CMAQ has a quirk that's kind of hidden. Maybe somebody who's a better modeler than I, which is most of the people in the room, can help. But there's something called MSIP that converts the fields that WRF generates and the clouds that it generates into something else and smooths the clouds over. And the clouds are what cause a lot of the boundary layer venting. So if anybody has any insight into how to help the states do that. Right.
So I think your point about that we need to follow the regulatory guidance. That's pretty valid. And I don't think we can impose all these more sophisticated approaches on the states, but it seems to me, and this is kind of the idea behind our reanalysis project, is that if we could define a reanalysis that was maybe provided by EPA that was at that course resolution, 12-kilometer components, and it had information about free tropospheric ozone and transport, say by satellite data, then that can provide kind of a base model for states to use for their subsequent. And I'm wondering whether Pat is still here, you know, whether it seems to me that that's the way. Then you've got the investment at kind of the gay level where it's running high resolution, coupled with memory asset and what we provide, and then use that as an embedded continental scale one. Is that something possible?
Well, I hate to put that on the spot, but EPA is in the process of developing, and is ahead of states in developing the 2007 platform. You know, I look to EPA to see if that's something that they would be interested in researching and actually building it into the 2007. I know that's one more task on a timeline that's already severely constrained, but it's an interesting idea.
I think we'll want to see some of the results coming out of it. Just me personally, struggling to look at the poverty analysis and certainly see how that informs your base case. And maybe going back to some of the comments I talked about yesterday, how well does that translate to the future? You go right back to sort of the model state that you project out to 2018. Those are some of the interactions that I just need a little more information about. So one quick thing about the model guidance, Jeff raised the issue. We're hoping to come out, that guidance has existed since 2007. We're hoping to have a draft out next month for the states to review and looking to finalize that. So it's not a formal EPA policy, so that we're looking to enlist as many comments from not just states but water. So look for that.
Yeah, sure, go ahead. Let me just state that in a SIP you're required to follow the guidance in your model. But there is something called weight of evidence that you can put in, where you can include modifications to the model, observational evidence. Of course, EPA isn't going to ignore it. They're not required to pay attention to it. Go ahead, a comment, and then Loretta, I think that's something.
I think it's
Please speak up a bit.
so I've said Brian Greenhouse. But when we did those 50 years, part of it also not only that, that the underlying system might be the same. So the new analysis would be present would be very different. And when you think about how the emission characteristics might really change, this measure 2 or 3, I would really shift. Well, we just move away from mobile sector and into other sector. So how do you adjust the principle? Very different.
So yesterday we saw some footage which talks about the stratosphere the influence there. I'm wondering how well CMAC, or how did it look to see CMAC the stratosphere influence, which would seem to be a big player at the high altitude sites of Washington. So even though it appears to be coming from Ohio, maybe there's some kind of stratosphere conclusions down or up to the influence in Washington.
Yeah, I'm not really sure how rigorously that gets built into the models. In general, most of our sites are very low elevation, and that type of influence would happen more on the shoulder seasons than in the heart of the ozone season. So that's something that I think would be very interesting to bring into the analysis, is a closer scrutiny of this kind of scale. Influence.
Yeah, I don't think it's in the standard regulatory CMAC runs. I wouldn't be there zipped at all. And this would be, I assume states always like to get these exclusions of exceptions for events. And you can demonstrate that the event was, Maryland got one for the, somebody showed pictures of the 2002 Quebec forest fires. We had an ozone exceedance and got that one excluded on the basis of it being beyond our control. So that's certainly a way in which we in ACAS can be of value to help you prove. If you get 200 ppb of ozone at Mount Washington and the carbon monoxide concentration is 50 ppb, that's pretty clearly stratospheric air. And it's a local intrusion, right. That's also possible. Yeah. So, go ahead, Arlene. And then Rich.
I'm just going to follow up question. So is there regulatory guidance for the modeling as to what is supposed to be for that collateral value? What do you use for that information?
We use a global run from Geoschem or GMI.
We actually double nested in the process. The first step is a geoscan, which feeds a larger domain modeling effort. And then we'll do a 36-kilometer run on a much larger domain. And the output from that will produce the boundary conditions for our subdomain. In terms of what's coming down from on top, I think Russ is right. I think we pretty much zero that out. And we assume that it's so stratified up there that it's not going to become influencing. And I think that might be something that we're learning that maybe we should be doing more.
Just to follow up on that, along similar lines with that potential stratosphere effect is something that might contribute to an overall background, depending on how you define background. But if someone was kind of running continuous background model, that seems to be an area that could be something. You know, along similar lines, I really think we should be working towards running the best possible model that we can afford to run in near real time. And archive those results and be continually comparing that. Because yesterday it was a little disturbing to hear about some of the disconnects between the inventory and the ability to run a forecast model. I think really it's a lot of resources and how we prioritize and be working towards the best possible model we can have all the time. Use feedback from various sensors that we can there. That's the way.
Great. Yeah, Tracy's been working on this.
Well, so just maybe switching gears a little bit away from the details of the models and one of the broader issues that states are facing. I was just, as we're looking at the last couple of years when the APAS initiative started to on my mind, is what is the types of deliverables or products or information that would really help in space? Because, we publish the scientific papers and we put those on our APAS website, but those take a couple of years to get published. And then we develop some tools, but I think, if you don't have that much time to learn new tools, the tools may be more or less helpful. And I'm just wondering, are there any formats or types of data or, wish list things that both for your own states and also more broadly, that, advice that you give to us in terms of how we should be delivering our results and how we should be that.
We'll open that up to anybody who wants.
So I have no regulatory responsibility for airplane, but what is clear to me is that the air quality that the public health folks are talking about, some data that's going to and that that information is not defined. So, listening yesterday, opportunity coming up, that's pretty exciting. Having the spatial distribution, being able to identify sources that are not available, better resolution on those. Paul talked about pilot the units. Those peaker units in New York City wellness centers. It's real hard to estimate what's happening. The load on that building and years. Yes. There's a lot of things happening. New York City is phasing out under 60 oil, which is used for building space heating as well as domestic hot water. So we'll be seeing that change over time as domestic hot water, as well as the change in fuels. And then I guess the last thing is we sort of put out the air quality solicitation a couple of months. So that ideas. We're looking for that. We have our website. It's built everything from this email, even more our advisors, variety of people.
Take from you from, I'll probably jump around three different related comments here in response to but the first one will be, it came out of some of the early presentations from Barbara and Lynn near roadway and special purpose monitoring. With changes in NAC, like 2 and other 2 to be more hourly, and monitoring requirements for roads, those are expensive. Monitoring is very expensive. To the extent we can get information that shows before those expenses have occurred that those monitors are needed or not needed, roadways or wherever, that would be extremely useful. Going off in a tangent, I'd like to go down level from Mount Washington to sea level. I think in terms of public health impact, our biggest issue in region in the Northeast is the New York City Long Island Sound. That's where we're going to have, that's our problem. You have your heads like monitoring. You have great resources, relatively speaking, to investigate Chesapeake Bay and all the recirculation. We have nothing like that for something's going on along the Sound. It may be very similar to what's going on in Chesapeake Bay. Maybe it's not that scientifically interesting. That's where all our people are living. And that's where the worst ozone problem. Something's going on. You have transport over Long Island Sound. Probably going to make New York City farther. And New York City is probably as elevated. It's not just going to be hard. They're a transmission constrained area, so they have a lot of generation within the city that isn't well monitored. We kind of need to get a handle, a lot better handle on what's going on in that. That's millions. Public health needs, research needs. I know everybody needs money. That, I think, is our biggest pressing problem. And my third point, going off a different tangent, in terms of forecasting, and listening to some of the challenges of using, and it's 2005 or older inventories to kind of project forecasting. One of the challenges I think we're going to have is a couple of major industry, especially in our region, which is a competitive market-based industry that basically power plants are dispatched on a before basis. So you can't really look at what happened during an NEI year the next day. And because of business confidentiality rules, we don't know which power plant is on a daily basis. And on high electric demand days, all sorts of things are going to go on. And I'm not sure how to predict. Maybe there's a way to predict. You can't predict a historical industry. It's really a market-based action. I don't know.
The first moderately hazy day slide I showed, I think it was PM that was a combination, I believe, of forest fire smoke and sulfur. I believe, because I didn't have any speciation data on it day, that I kind of patched it together with models and Jason's days and other information. It reminded me that I've recently been involved in 2 very unpleasant efforts to reduce the size of speciation networks. Food program, on one hand, and the EPA speciation network program on the other hand. That proposal, I think, is going to be coming soon. Very expensive. There's a need to reduce the size of those networks, which provide a lot of useful information from a lot of different perspectives. But I really think it would be great to get the most sensing community involved in that discussion process of how we maximize the resources. you can tell us more than just where it's off the deck, you can provide information about chemical composition and so forth, and to be able to kind of maybe not only just fill in the gaps and do the replacement, but to coordinate the two efforts together. You know, whether it's very easy. That would be my perspective on how you could help us.
I wanted to echo what Paul said, but in addition to sort of informing whether or not it's useful to undertake a monitoring effort, I think that one of the big problems is that you don't, even if you have some monitoring results, you don't really identify sources. And that's a particular problem with something like EM, because the background of transport, there's also, wind blowing dust, and, there are a million different sources. And to really, for instance, we have a big battery and a lot of things, and they want, we've done some monitoring, they want more monitoring. I just don't think it's going to be certain questions like doing that, because I feel at a disadvantage because yesterday I'm not really familiar with what you guys do. But I guess I feel like if there's any way using satellite technology to kind of show how things vary in distance, or just be able to identify, that would help identify sources and the times that all do. It would be very helpful.
Ivanka and Daniel.
Thank you.
Go ahead. And then Ivanka, and then Daniel.
Now, the air quality management, I'm thinking about the resources, ecosystem, lakes, forests, and what the NASA do there is like to air quality deposition. And I bring to your attention, EPA, we had a case like this, I was in panel with Greg and others. We spent 4 or 5 years looking at the protection of discarded aquatic, terrestrial, enrichment, all of this. So we made a recommendation. We had a standard modified acid. Look at that formula. And but anyway, we proposed it, and it has modeling exercise feedback, and one more thing that we have not talked about here, ammonia, because reactive nitrogen is not only oxidized nitrogen, also is nitrogen. So we went through this exercise. EPA then decided to go and measure the ecosystem. Literally, and I'm wondering, and Brian's here, and Ben was here, and others, not that I know the answers, but I know EPA might be starting that process again, we're going to animal to protect people. And what could be done with respect to the landscape, the forest, the soil capacity, of the irrigation capacity, all of these. So there's quite a number of things where I think that's what we've done on a natural basis. To the extent Northeast, we have the country able to forest. So I think it's a great benefit from NASA's at least understanding of what EPA was trying to do. And I could bring passion into the thing too. And Rich was part of the panel, and I did ask this question.
Okay, let me. Does the panel is ammonia on your radar screen yet? Other than as a PM precursor, maybe that's enough.
I mean, it's an unmeasured component typically that's really important. It was proposed to be measured in the EPA pilot network that came out of that master that Dean mentioned. Pilot network think one site, my site, Vermont, got one additional ammonia monitor there. But, there were other aspects of that proposed maps that included, for example, measurements of SO2 and SO4 together, two things which I would think we could provide remotely, perhaps, as well as especially since we're purporting to apply those concentrations of the broad ecosystem areas, not just possibly reduce some, and also the remote sensing to sense effects on the ground, certification, registration, is common.
Yeah, my thoughts are, is it on the radar of the states of our people? Then you can count this, like, for ammonia and methane as well. The sources are out in the Midwest, so these are ag, agricultural operations. So, in terms of what a state in the Northeast can do about it, it's somewhat limited. Maybe New Jersey, California, maybe that's all you can do. But in general, it's like, is it something? One, is it a problem? And then is there something to do about it? As a state? So in that sense, I would say it's not necessarily on the radar of states in the Northeast, but as with the transport 2.5, it's simply information developed that it contributes to a transport problem, and then we try to get to a regional and national approach to deal with things. States collectively stand together and work towards that. And that political issue, change of the action, very, very different.
To be clear, my question was really much larger than only about the big thing. But I think the overall, the secondary standard establishment for SOx and NOx and work has occurred and might occur in the future where the satellite NASA will be helpful.
Yeah, ammonia is one of the things that's is sometimes detectable remotely. Ivanka, I think, had a comment.
We make them available and any of the states and often not connected. And that's really one of the ways we see that how well
Yeah. Great, Danielle. And then Dan.
I want to get back to methane. We've heard from a few speakers about the transition from coal to natural gas that's going on. Well, does it come higher emissions of methane? And you might say, well, that's partly from generation in the Midwest and the center. Well, yes, but it's to feed New England. And is there some feeling of responsibility for that in the context of Reggie? And what about those dairy cows? Dairy cows are huge sources of methane. 10 times more efficient than beef cows because it has to be in confined environment. And does Vermont feel some sense of responsibility?
Yes. Actually, this last week, one of the guys who works for me completed his testimony on the proposed pipeline, natural gas pipeline would extend Vancouver Vermont across the lake into New York State to ultimately down there. It's burning some really dirty fuel right now. But the question was what about leakage and the methane leakage and that sort of thing. No way. And we were arguing with the applicant over their quantification of increase. That's one twist on that. It's increasingly something that's looking at. We also have a registration fee system where we charge Research University. This past year, we started talking about, could we think about adding methane to that list? Kind of using, we tried to consider a carbon fee in the past and got shut down. We thought maybe we could sneak methane in because both a climate forcer and an ozone precursor, near-term climate forcer. But then we said, well, wait a minute, why wouldn't we do that? And if there were opportunities for strategies, which I haven't heard some side conversations, but maybe there are, that would be something that would be great to know about. And in addition, if we had a way to quantify that and show people a picture of here's methane emissions that are seen in space, that would be nice.
Yeah, right. Well, because of Jim Galloway, I had what I call my summer of manure at an academy panel on animal feeding operation. And indeed, you can't put a catalytic converter on either end of a cow, but you can control what they eat and the bacteria in their very complicated guts, their iophones and other sorts of antibiotics. Anything that turns into methane is not turning into beef or milk, so cattlemen, dairy farmers, they don't like methane. That's of no value to them. So there are things that can be done. That's not necessarily something ACAST wants to be involved in, but certainly quantifying the emissions, remote sensing techniques, numerical models, these are where we might be helpful for methane. Okay, let me hang on. I'm going to let Paul say something, and then Dan had his hand up, then we'll go back to the middle.
Just a quick comment on methane. Maybe the time scale is longer than the regulatory time scale for the payment. One of the fast max reviews was the most recent comment devised max. We did comment on it. One of the things we did was like methods is reducing methane levels and looking at what it does to reduce the ozone. There is a signal, a pretty big signal. And that was actually the context of the secondary standard, the welfare-based standard, the longer-term standard. That was one of our arguments for methane to run a longer-term standard. But as you know, for safe regulatory purposes, for short-term ozone radar, and we feel it's a responsibility of ours. I think more it's an opportunity.
As opposed to Reggie.
Reggie is purely CO2.
Yeah, Reggie has not expanded to other greenhouse gases yet.
But states, Massachusetts, Rhode Island, states have state greenhouse gas statutes that are longer term and incorporate all these things that could keep us in states are not ignoring. And so once again, in this sources,
Hey, where was I? Dan.
We have the opportunity to have these panels with ACAST, and I have the opportunity to explain things to enterprise lots of time. Next time, they're always great for helping us understand what each of you in the states and interstate organizations are facing, the timelines that you're on specific. Right. We're thinking about this broader question that Danielle posed to us: how can science applications inform air quality management? We're really assessing how can ACAST for all of this air quality management. To what extent is it most helpful for us to be addressing these specific questions, rules, deadlines that you're facing? And to what extent are you fully focused just being those? And to what extent is there a role for us to maybe show ways that things can be put together in different ways? Our ultimate goals are really to improve human health, to reduce greenhouse gas emissions, and achieve other benefits for the environment, such as vegetation, agriculture, facilities. But those are our three main goals that may or may not be best addressed by the rules as currently formulated. To what extent are you open to working with us on ways that look at the bigger pictures beyond the month-to-month rules?
I've talked about that. The rules are driven by what the Clean Air Act says. The Clean Air Act is written by Congress. You can't change certain parts of the Clean Air Act through timelines. So, in that sense, that's just the nature of the planning process. But obviously, the states have been working collectively trying to do regulatory drivers. And when it comes to changing rules, it's that's a dialogue with EPA is constantly going on. So there's always openness to try to do things within the rules, but also more consistent practices. But
That answer that we're not covering the rules. But we try to, we don't have, maybe you don't need that answer today, or next year, if we need to find it out. And then we get surprised. Biolabs was a very secure issue. We were asked by sister agencies for getting around problems. And if you develop a, some emission control technology, for this outdoor footwear, we move that back into we can sort of we saw out manufacturing put out that line specifically at that time. Just like in the market, and now this big renewable energy didn't come from staff stuff. Really, they contributed outlets for their byproducts. It was for their had we gone to some large, what we did in the industry without advanced technology, we would just go ahead. So, you can't predict everything, and sometimes you get lucky. So, you're definitely
I was going to add that because of the way the standard is, that we have a lot of documents that we have to review at any given time. Whether or not they seem to be ability, that are important. I think it's all the more reason that we need to rely on scientists to be able to look at things in a different perspective and answer questions that we have to go to staff all the time. But I think it's all the more important.
There were a couple of comments right in the middle that I'm going to give the panel the last say because we're running a little bit over. So, Brett, okay, and then
I want to go back to what Rich said earlier on about this people experience with cycle. And I think that's an area where maybe ACAS could act as a part of the tempo, the planning for tempo is to tie tempo validation to a federated to enhance specific ground sites with column measurements so that you could get an idea about what the satellite is doing what's on the ground, and maybe a longer term action for ACAS to see how that validation plan for tempo fits supporting states and
that's great. Well, they haven't built Tempo yet, right? So we can. So you can tell them what the resolution should be. Talking about 1 kilometer.
Validation
for geostationary.
Validation
is raise the budget.
So that's going on now, and EPA is planning on how to support that in the strengthen the
Okay. Yeah. We should have a discussion about the spatial and temporal resolution of Tempo, but I don't want to get Kelly started because just wax eloquent for an hour.
A quick feedback on that too is that with the reduction of the EPA chemical speciation network, the plan, as I understand it, and this is mostly an EPA effort, but the plan was to get a little bit more than they thought they needed to, so they have a little bit extra to devote to enhancing maintenance in good ways, and that how could we better enhance it? Discussion is kind of unfolding now.
Okay, the last comment from ACAST. Audience.
mechanism, just get on back, just wow. It's a fraction of 1 billion of they become as a model. So that's what the model gives you. That's all it is. So you think we get the big bang for the buck. See if you can measure that in the environment if you want. That's another thing. It's running through the model. That's what how.
Are we going to see the toxin? Basically, the toxin. It's not all. But just because you mentioned that, Howard, there's two things to think about in the modeling is what happens when peak ozone, we've seen modeling 287 parts per billion peak ozone, which is not insignificant from a regulatory point of view. And the modeling, from what I've seen, cut off around 2022, but Tier 3 is not just gasoline, it's fleet standard, and that fleet turnover, we don't project to happen completely until 2025 to 2030. So where you stop in your modeling becomes a lot about what you say about the
okay. Yeah, I guess there's a lot we don't know about what the impact of Tier 3 will be on tailpipe. Models are fine. I'll give the panel one last opportunity. You have all these you're brilliant but nerdy scientists in front of you. Put them to work. Yeah.
Okay. In terms of sort of adding cleanup on this session, again, thank you for having us involved. Please don't let this be the end of it, though. I mean, put your science in front of us. Keep the communication going. We operate in an open environment, and we welcome input. We'd rather have it before so that we can work with it as opposed to after when it's key. All these things are great ideas. I wish we had this sooner. So please keep the information flow going. I'm just going to touch on a couple of these bullets here real quick. As the standard goes down, the fine details start becoming more and more important, and we're going to have to start getting a lot of other things that we didn't really need to get right before. We're going to have to get right now. So having things like satellite to help corroborate whether or not the models are working right, whether or not we're getting the emissions right, really good stuff. You know, I want to be able to build on that. Natural gas and oil, we've got some emission inventory data. I don't know if we really feel like we've got great confidence that it's all right. I know there's some exciting satellite work that's being done on this. I'd like to be able to cross-check this information with what we're putting into the models to make sure we're getting something. Supreme Court, got to go back to the picture of the Supreme Court. It's a good thing that the Supreme Court goes down this road in the sense that it gives us a mechanism for regulatory approaches. I'm not so excited about CASPER itself because it's really focused on an older ozone standard, focused on the 85 parts per billion standard, not the 75, not the 60 to 70, which without the venture. Well, it's great that we have a mechanism, but we really need more. And how that more gets developed, your science here is going to help you guide this. So, again, thank you.
Okay, let's thank our panel.
Yes, I hate to be coercive, but for group photo I have to. Otherwise, we keep waiting for each other forever. So let me ask that you all venture on this side of the building. It's on the steps of Child's Hall, where Brenda will be taking our collective picture. If you're not quite sure, just follow the locals and don't stray too far. This room is not secure. So, yeah.
Right, yeah, the models have extremely well, no, you're on to something very important. Working on that. The models have a very hard time separating whatever boundary conditions are at the end of your domain, whatever your domain is defined as, and what you kind of bubble up out of the boundary layer, and then down the model is not bending the boundary layer the way it should. If you run it at 12 kilometers, 4 kilometers,
That's not.
That's we're going to be able to do with our school training.
I know, but 4 kilometers is not, 3 times more expensive.